The next factoring technique that we want to look at is factoring a difference of squares. Examples 24 and 25 should say to expand the product of the binomials below, but hopefully we get the idea here. We want to expand these out, FOIL these out, to pick up on the pattern of what happens with these particular types of problems. In this case, expanding this out will give us b squared minus 2b plus 2b minus 4. Our two middle terms will cancel out since those coefficients are opposites, leaving us with b squared minus 4. In 25, we'll have 16a squared minus 12a plus 12a minus 9. And again, our middle two terms will cancel out since the coefficients are opposites, leaving us with 16a squared minus 9. The pattern that we can pick up on here is that in each case, the binomials that we were multiplying together were nearly identical. The only difference was that one had a plus sign, one had a minus sign. Otherwise, the terms are identical in those two binomials. And what we end up with is some quantity squared. In this case, this is 1 times b squared and 2 squared. And in example 25, 16a squared is the same thing as 4a squared, and 9 is the same thing as 3 squared. So when we expand the product of two binomials that are identical except for the sign in between the terms, what we end up with is the difference of two perfect squares. So if we have the difference of two perfect squares, a squared minus b squared, then that will always factor as a plus b, a minus b. And again, we can use that trick to more quickly factor specific expressions. In example 26, also got an error here. These are obviously binomials since we only have two terms. We want to factor the binomials in examples 26 and 27. We need to check that our value in the first term and value in the second term are perfect squares. This is the same thing as 4y squared, and 49 is the same as 7 squared. Since we have two perfect squares, we can go ahead and factor this as 4y minus 7, 4y plus 7. Similarly, in example 27, 25x squared is the same thing as 5x, that quantity squared, and 16 is equal to 4 squared. Since we have the difference of two perfect squares, we can factor this as 5x minus 4, 5x plus 4. So noticing when we have difference of squares or a perfect square trinomial gives us some techniques, opens the door to some techniques that make this factoring process quicker by following these patterns.